Please let me know if I am audible to you. Let me know in the comments. Let me know if I am properly audible to you. Those who are joining the live, please let me know if I am properly audible. Okay. So we will wait a couple of minutes for everyone to join and then we shall start. Hello everyone. Hello those who are joining. Today we'll be doing using the concept of rank and do questions of system of equations. Okay. So let's just wait a couple of minutes for everyone to join up and then we shall start. Hello, hello Aditya, hello Shushpita, hello everyone. Please wait a couple of minutes and we shall start our topic today. Okay, hello everyone. Okay, so let's get started with our topic. Hello, hello everyone, those who are joining. All right. So let's not waste any time. People will keep joining. So today our topic of discussion is system of equations, and you will see that in the present years, in the last 2 3 years, every stream of engineering, there is always one question from system of equations. Okay. So first, let us classify the system of equation into two categories. Okay. The first category is if we have a homogeneous system of equation, and the second category is if we have a non-homogeneous system of equation. We are mostly concerned with the non-homogeneous part and a bit less concerned with the homogeneous part. Okay. Majority of the questions are constructed from the non-homogeneous part, and sometimes there are questions from homogeneous part. Okay. So first, let's understand the basic difference between the two. When I say homogeneous, let's say I am creating all my examples with a 2 cross 2 set of matrix. That means two equations and number of variables can be more or less. That's not a problem. But I'm going to deal with only two equations. Whichever example I will create, I'll create it with two equations. So homogeneous means when the constant part is zero, that means my system of equation looks something like this: a1x plus a2y equals 0 and b1x plus b2y equals to 0. When my constants are 0, this is a homogeneous system of equation. Okay, this is a very simple system of equation. If these constants are non-zero, or at least one of them is non-zero, it falls under the category of non-homogeneous. That means we'll have our system of equation in this manner: equals to some a3 b1x plus b2y equals to some b3. So when these constants are non-zero, it is going to fall under the category of non-homogeneous. When the constants are zero, it is going to fall under the category of homogeneous. Okay. So I've just constructed a very simple example. Now the things that can happen from here is that a homogeneous system of equation, it can have two possible natures. Two possible natures in the sense this can have either a unique solution or it can have infinite number of solutions. Infinite number of solutions. There is no other alternative to this. Either in unique solution or or infinite number of solutions. There cannot be a scenario where there is no solution this scenario shall never occur in case of homogeneous system of equations. Now, why this will never occur? Because if you check, let's say when x value is 0, y value is 0. Okay, if we put these two values in the equation, if you put x0, y0, you can see the first equation is satisfied. If you put x0, y0, the second equation is satisfied. So 0, 0 is by default a solution of a homogeneous system of equation. So that means one solution always exists. This solution is always there in the system. So there cannot be a scenario that this system of equation will have no solution. There cannot be such a scenario. Okay. Either it will have a unique solution or more than one solution. Okay. Also, this kind of scenario also cannot happen that we can say there are 5 solutions, 6 solutions. No, not possible. Either just one solution or infinitely many. There is nothing in between that. Okay. So when I say unique solution, now I have already said that 0, 0 is a by default solution. So unique solution means just one solution. So that means when I'm talking about unique solution, this is the only solution this system of equation has. 0, 0 is the only solution. When I'm talking about infinite solution, I'm saying that 0, 0 is a solution, and other than this, there are other solutions also. Other non-zero solutions also. Okay, so this is the complete picture. So a homogeneous system of equation can have unique solution or infinite solution. If unique solution, then 0, 0 is the only solution. If infinite solution, then 0, 0 is one of the solutions. Other than that, there are some non-zero solutions also. Okay, and we have a special name to this. These non-zero solutions, these are called non-trivial solutions. Okay. And the 0, 0 solution, this is called a trivial solution. So we usually use these special names. We say non-trivial solution. When we say non-trivial, it means the solution which is not the 0, 0, 1. The other non-zero solutions, they are called the non-trivial solution. And 0, 0 is the trivial solution. So homogeneous system of equation can either have trivial solution or trivial along with some other non-trivial solutions also. This is the scenario. Now, what is the condition for this? Unique solution, if the coefficient determinant over here would be, my coefficient determinant is these coefficients. Okay, a1, a2, b1, b2. So a1, a2, b1, b2, these are the coefficients. If this determinant, if determinant a is represented by this, if the determinant is non-zero, then the system of homogeneous equation will have a unique solution, which is the 0, 0 solution. Okay, if the coefficient determinant is equal to 0, then this system of equation will have infinite number of solutions. Okay. So this is the category for homogeneous system of equation. This is a simple category. You will not expect questions from here because this is very simple. We are mostly concerned with the non-homogeneous part. Okay. So now moving on to the non-homogeneous part. Again, this part I can categorize into 3 categories now. Okay. First category is unique solution, which is same as before. Second category is infinite solutions. And the third category is no solution. So now we have 3 categories for non-homogeneous system of equation. Okay. Now for the first 2, the criteria remains same. The criteria will not change. Determinant of A not equal 0, determinant of A equals 0. The criteria remains same. Okay, so for unique solution, determinant A is non-zero. Okay. For infinite solution, determinant A is equal 0. Okay. For no solution, again the same criteria, determinant A equal to 0. So now suppose I have a system of non-homogeneous differential equation. I have found the coefficient determinant, and let's say the coefficient determinant is non-zero. Then I directly make my conclusion that it has exactly one solution. It's a unique solution. What that solution is, we don't know. We just know it has a unique solution. But if the determinant becomes 0, now there are 2 possibilities with us. Either it is having infinite number of solutions or it is having no solution at all. But we are unable to decide either this case or that case, which is happening. We are not able to decide just from the determinant. So we need some extra criteria. So now the rank idea comes in. The rank of the matrix, augmented matrix A augment B. Now what is A augment B? A augment B matrix, it is going to look something like this. If I say A augment B, this matrix is going to be, firstly I will take the coefficient part, which is A1, A2, B1, B2. I'll take the coefficient A1, A2, B1, B2, and I will make some dotted line, any line, just to distinguish it with the constants which are on the right side. The constants are A3, B3. I'll copy the constants also. So this matrix is called the augmented matrix. The rank of this matrix has to be equal to the rank of just the A matrix. Which is the A matrix? Just this portion is my A matrix. Okay. So just this portion is my A matrix. The entire thing is the augmented matrix. So the rank of the augmented matrix has to be equal to the rank of the original matrix, and along with this, all these ranks must be less than the order of the matrix. Okay. Supposing that it is having n number of let's say equations and n number of variables. Okay. So considering that, the order, it must be less than the order of the matrix also. Now for no solution case, the rank of the augmented matrix must not be equal to the rank of the matrix A. Okay. They must be unequal, and obviously they will be less than the rank of, or less than the order of the matrix. We are not concerned there. Okay. So I will erase out this condition less than n, because we don't usually require that criteria. It's a theory. We need to know that the rank will be less than the order, but it will not be required anywhere while solving problems. So I'm not giving out unnecessary conditions here. Okay. Just this much condition is enough, that rank of the augmented matrix, if that is equal to rank of the original matrix, obviously it will be less than the order. I'm not saying that. Then it falls under the category of infinite solution. If they are unequal, then it falls under the case of no solution. So this is the distinguishing criteria. Now there are some names we give to these kind of situations. If a system of equation has unique solution or maybe infinite solution, we say that the system is consistent. If the system has no solution at all, then we call it inconsistent. Okay, we call it inconsistent. These terminologies are important because the questions are framed using these terminologies. Okay. So if a system of equation is given to us and asked what is the criteria for inconsistent solution, you should understand that they are asking for no solution case. For no solution means determinant non-zero and the ranks of the two matrices unequal. Okay. If we are talking about consistent, then there are two possibilities inside consistent, either unique or infinite. Now, based on the further information in the question, we shall proceed accordingly. Okay. So I hope this entire picture is clear to us. What is happening? This is the entire picture for homogeneous and for non-homogeneous. We are mostly concerned with the non-homogeneous part and not with the homogeneous part. Okay. All right. Any questions up till now? Anyone? Please ask. Then we shall continue with our problem solving. Please let me know in the comments if things are clear up till here. Okay. No questions. Well enough. So proceeding from here, let's start solving some previous year questions. So let's take a look at this question. All right, we'll come to this question at the end. Okay, remember, we'll come back to this question at the end. Let's start with this question. So a matrix A is given to us, a matrix B is given to us. The system of equation has been represented by Ax equals to B. So basically, whenever a system of equation is given to us, its representation is Ax equals to B. Okay. Then which one of the options is the correct condition on B1, B2, and B3? Okay. So this is just the question which has come this year. Okay. This year, GATE Civil Engineering, this question has come. Okay. So it is asking for the system of equation to be solvable. Solvable means it cannot be no solution case. Okay. Achha. Here, if I write the equation format, I'm just doing a few things for your better understanding. I have something like this: 1, 1, 1, 3, -2, -3. Let's say the variables are x, y, and z, and the constants are b1, b2, and b3. B1, b2, and b3. So if I multiply out the equations here, if I write the equations one by one just by multiplying, so I'll have x, okay, a, so wait, just a second, b1, b2, b3, x, y, z. For solvable, which one of the following options is correct? Acha, there seems to be some problem with this question because the multiplication here is not possible, right? The multiplication is not possible. I have how many number of rows? I have 3 rows and 2 columns, and obviously my x vector, if that is 3 cross 1, then the multiplication is not possible. So obviously I have to understand here that my x does not have 3 variables. Okay, so the moment I've written this, I've done a mistake, right? So this should be xy, so that number of rows becomes 2, and now the multiplication is possible. Okay, so I framed the question in a wrong way. The number of variables should be x and y, not 3 variables here. Okay, so now my multiplication is possible. If I multiply x plus y equals b1, x plus 3y equals b2, minus 2x minus 3y equals b3. So obviously you can see that here we have 2 variables and 3 equations. Okay, so it is asking that this system of equation has to be solvable. Solvable means either it can have a unique solution or it can have infinite solution. The no solution case cannot happen. Okay, so either this can have unique solution or it can have infinite solution. Okay, any two of this. Now if I come back over here, the idea for unique solution and infinite solution, the difference between them was determinant non-zero, determinant zero. Now here, these conditions I cannot apply. Why cannot I apply these conditions? Because this is not a square matrix. Determinant property will work only if you have a square matrix. So this is a rectangular matrix, so you cannot use a determinant property. Okay, so that means obviously you have to use the rank property over here. The rank of A augment B, that has to be equal to rank of A, and the entire thing has to be less than the order of the matrix. So let's see how the rank works out. So I don't need so much information right now. This was just for a better understanding. I just need to find the rank of the augmented matrix. So I'll take the augment part also. This augment with B1, B2, B3, B1, B2, B3, because my answer has to be in terms of B1, B2, B3. Let us start to simplify this matrix by doing some row operations, and let's try to find the rank of the matrix. Okay. Achha. So the first thing to find a rank was, with the help of this one, we'll try to make these positions 0. Right? We try to make the elements below the first non-zero element 0. So for that, obviously, I have to do the operations as R2 dash equals R2 minus R1, and R3 dash equals R3 plus 2 times R1. Right? So if I do these two operations, I will be having 1, 1, B1, and 0, 3 minus 1, 2, B2 minus B1, and then 2 times first row, adding it with the third row, that will make it 0, minus 1, B3 plus 2 times B1, right? So we are getting something like this. We want to make further things more simpler. Okay, so we are trying to reach a position where the entire row becomes 0, so that the rank becomes less than the order. Okay, we are trying to achieve to such a position. So now I want to make this position as 1, and with the help of this position I want to make the element below it 0. So the first thing that I will do is I will divide this position by a 2. Okay, so what I'm doing is I'm dividing R2 by a 2 to just speed up my calculation. I want to do it properly with all the steps. So 0, 1, B2 minus B1 by 2, 0, minus 1, B3 plus 2 times B1. Right? Now with the help of this one, I want to make this position 0. So now again I will do the row operation as R3 dash equals R3 plus R1 as R3 plus R2. Okay. So if I do this 1, 1, B1, 0 1, b2 minus b1 by 2. If I add up these two rows, so it's 0 0. I'll do this calculation in the side. So I'm adding this with the element above it. So it's b3 plus 2 times b1. Along with that, I'm adding the element just above it, which is b2 minus b1 upon 2. So if I do this calculation, it turns out to be 2b3 plus 4b1 plus b2 minus b1 upon 2, which finally turns out to be 3b1 plus b2 plus 2b3 whole upon 2, right? So this position becomes 3b1 plus b2 plus 2b3 whole by 2, right? Now let's establish our criteria for more for the thing to be solvable, right? For the thing to be solvable, I can see this portion has become 0, right? So that means the rank of the A part, this is the A part, so the rank of the A part, one of the row has become 0, the other two rows are not 0, and we cannot simplify it any further, right? So the rank of the A part is 2. Now, if I consider the entire matrix, so if I consider the entire matrix, which is the augmented one, okay, so the rank of the augmented part, this also has to be equal to 2. If it is unequal, then it will go to the no solution case. But the question is saying it has to be solvable. So I cannot go to the no solution case. I have to make this rank equal to this rank. That means I have to make the entire rank 2, right? So the entire rank will be 2 if this position value becomes 0, right? If this position becomes 0, then the entire row of the augmented matrix becomes 0. So then the rank of the augmented part also becomes 0. So that means this position has to be equal to 0. That's the criteria we are getting. So that means 3b1 plus b2 plus 2b3 upon 2 has to be 0, which means 3b1 plus b2 plus 2b3 has to be 0. And if we now look at the options, this is given in option number B. 3b1 plus b2 plus 2b3 equal to 0, which is our option B right over here. Okay. All right. So tell me, is this problem clear to everyone? Yes or no? Those who are watching the live right now, I would request everyone, please share this live among your friends, because I can see the audience is too low today, right? I can see a very low audience right now. So if you could just share this among your friends who are preparing for GATE, that would be great. Okay. All right. So let me know if this is clear. We'll move on from here. Come on, let me know. Is it okay? Shall I move on? Come on, give me a yes or no, guys. Okay, so moving on from here, let's solve this question. Okay, be careful whenever you have something like this, is R. Okay, be very careful whenever you have an is slash R in the question. It means that the question can have more than one correct option. Okay, the question can have more than one correct option. Be careful about it whenever is or R has been given in the question. So it is saying that consider the given system of equation for variables x and y where k is a real valued constant. Which of the following option or options are correct? And there are 4 options, and this is my system of equation. Okay. So now let's master the art of solving the question. Okay. We don't want to read all the options one by one, then think about a question. The moment we have got our system of equation, the very first thing should be write it in the matrix form. Okay. We'll think about the other things later. The very first thing we'll do, we'll write the augmented matrix. So I can see the coefficients are 1, k, k1, and argument on the right side I have 1 minus 1, right? So this I can see is my augmented matrix. Okay. Now the question is asking, there is exactly one value of k for which the above system of equation has no solution. Okay. Now for no solution, let's figure out all the cases here. If I say that the system of equation has unique solution, for unique solution, what was the criteria? The criteria was the determinant part had to be non-zero. The criteria was determinant had to be non-zero. Now, what is the determinant value over here? The determinant value, if I do the multiplication, that's 1 minus k square. Right? So 1 minus k square has to be non-zero. So that means k square not equals 1. So k not equals plus minus 1. So that means k can be any real valued constant other than plus minus 1. So k can be any real number other than plus or minus 1. Right? Now the first option is saying there is exactly one value of k for which the system of equation has no solution. Okay, we haven't yet created the criteria for no solution. We'll come to this later. There exists an infinite number of values of k for which the system of equation has no solution. Again, we don't know anything about no solution yet. There exists exactly one value of k for which the system of equation has exactly one solution. There exists exactly one value of k for exactly one solution. We can see that's not true. There exist many values of k for which there is exactly one solution. All real numbers except plus minus 1 satisfy the criteria that there will be just one solution. So obviously option C is not true. We know that. There exists exactly one value of k for which the system of equation has infinite solutions. We don't know that yet. So now unique solution case has been studied. We don't want this anymore. Now we want to go to the case where we are getting infinite solution or no solution. So for that, the first criteria would be determinant equal to 0. Now determinant equal to 0 would be 1 minus k square equal to 0. That would be k equals plus minus 1. So for infinite number of solutions, determinant has to be 0. So that means determinant 0 means k value plus minus 1. Okay. Now along with that, we need one more thing, that we need the rank of A to be equals to rank of A augment B. Okay, so let's find the rank also from here. So with the help of this one, we are trying to make this position 0. So that means this is the operation we are trying to do. R2 dash equals R2 minus K times R1. If we do this, so 1K augment 1. If I do this operation, I'm getting 0. And R2 minus K times R1, that would be 1 minus K square. And R2 minus K times R1, so minus 1 minus K. Right, so we are getting something like this as our simplified matrix. Okay, so now if k value is plus 1 or minus 1, if k value is plus 1 or minus 1, I can see this position is 0. Okay, so obviously I'm taking 1 minus k square equal to 0, so this position is becoming 0. So that means the rank of A part has become 0. Okay, the rank of A part has become, rank of A part has become 1, right? Because the second row is becoming completely 0. So rank of A part is 1. If k value is plus 1, then this value becomes minus 2. If this is minus 2, then the entire augmented portion rank becomes 2, which will be unequal to the rank of A. Okay. But if it becomes unequal to the rank of A, that means we are going to no solution. But right now we want infinite solution. If k value is minus 1, if you see, if k value is minus 1, and if you put that value over here, then this value also becomes 0. Then rank of A augment B also becomes 1. So that means corresponding to k equals minus 1, we are going to get infinite solution. For k equals to 1, it is not working out. Okay. So we are getting exactly one value of k. We are getting exactly one value of k for which the infinite solution case is happening. So option D is saying there exists exactly one value of k for which the system of equation has infinite number of solutions, which is true. Okay. Now coming to the no solution case. Now if I take k value as plus 1, obviously this portion is still 0. So rank of A is still 1. Then if k is plus 1, then minus 1 it becomes minus 2. Then rank of A augment B, that becomes 2, which is not equal to rank of A. That means if k is 1, it is going to no solution case. Okay, so there exists exactly one value of k for which no solution is happening. So let's go back to option A. There exists exactly one value of k for which the above system equation has no solution, which is true. There exists infinite number of values of k for which system of equation has no solution. That's not correct. We're getting exactly one value. So that means option A and option D is correct. Okay. Does this make sense? Come on, give me a yes or no. Come on, the participation is too low today. Come on, guys. Keep up the chat. Tell me, is it okay? Shall I move on? Okay. So let's take a look at another question. A matrix is given, a B column matrix is given. Again, a system of equation Ax equals to B has which of the following? Again, this is a question of 2025. Okay. So first thing, whenever you have a matrix system of equation, convert it into a augmented matrix. So my augmented matrix, that would be 1 1 1 minus 1 minus 1 minus 1 0 1 minus 1. Augment the B value, this is the constant value, 1/3 minus 1/3 and 0. We have got our augmented matrix. The question is asking which of the following will happen: unique solution, infinite solution, finite solution, no solution. Now I told you there is no other case, there is no case called finite number of solutions. Either unique solution or infinite solution or no solution. There cannot be any other possibility. So option C doesn't make any sense. Option C is wrong in any scenario. Okay, finite number of solutions never possible. Either unique or infinite or no solution. Now whichever is the case, you have to find that out. So the first thing you should do is you should check for unique solution, because that is the easiest one. How will you check for unique solution? Take the determinant of this. If the determinant value is 0, if the determinant value is 0, non-zero, then unique solution. So first check for the determinant value. So from here, if I take the determinant of k, if I expand this along the, let's say if I'm expanding along the last row, okay. So the first element is 0, then first element is 0, then minus 1 times, if I do this calculation, I'll be having minus 1, minus of minus 1 plus 1. So minus 1 plus 1, that becomes 0. Minus 1 times, if I expand along this, I will have minus 1, minus 1, minus 1 plus 1. So again, that is 0. So that means the determinant is becoming 0. So determinant 0 means unique solution again out of the picture. So either infinite solution or no solution. For that, we just need to do the rank of the matrix. Okay. So from the determinant, we have figured out that unique solution is out of the scenario. Okay. Now for infinite or no solution, the only way is to find the rank. So with the help of this one, we'll make this position 0. The one below it is already 0, so nothing to be done. So we are going to do the row operation of R2 dash equals R2 plus R1, and that would be 1 1 1 augment 1/3 0 0 0 0 and 0 1 minus 1 0. So we have got a completely 0 row, so we don't want it in the middle of the matrix, we want it right at the bottom, that it's easy to handle. So we'll just interchange the rows here. So we'll make it look like this: 1 1 1 augment 1/3. I am just bringing the third row up to the second row: 1 1 minus 1 0 0 0 0 0. Okay. Now from here we can see that it is not, we can still simplify a little bit further. We can, with the help of this, no, we cannot simplify it any further. It's done. The moment we try to make this 0 will be lost. So we have reached our echelon form, right, for the rank of the matrix. Okay, because the elements below the diagonal have become 0. Sorry, the elements below the diagonal is 0, so our echelon form is reached. Now we just have to understand the rank of A matrix and the augmented part. The rank of the A matrix from here, the rank is 2 because one row is fully 0. If I take a look at the entire bigger picture, then the rank of the augment part, that is again 2 because still the last row is completely 0. So rank of A augment B and rank of A are same and they are less than the order of the matrix. So that means this is going to infinite number of solutions. Okay, so all questions of system of equation ultimately comes down to finding the rank of the matrix. That's it. Okay, so moving on from here, come on, I hope you should be able to do this question on your own. Do this question and tell me the answer. The value of C for which a system of equations has an infinite number of solutions. Very small system of equation. Just write it in the form of augmented matrix and find the value of C. That's it. Let's see if anyone can answer this question. Okay, I've got one answer is 4. Let's check that. 1, 2, augment C, 1, 2, 4. So if I want infinite number of solution, obviously the determinant part is 0. That can be observed. Both the rows are same. Okay, so for infinite solution, if I just do a one small calculation for rank, which is R2 dash equals R2 minus R1, that would be 1, 2, and C, 0, 0, and 4 minus C. Right. So now for infinite number of solution, here I can see rank of A has become 2. So that means this position also has to be 0 to make the argument. Sorry, rank of A has become 1. Sorry, rank of A has become 1. So for the argument part, the rank will be 1. If this position is again 0, so for this position to be 0, we should be having C equals 4. So my answer becomes 4. Right? Simple question. Do this one. This is also a very easy question. System of equation has no solution. Okay, so here the condition is no solution. What value of C will have no solution? Now see, let's take a basic example, a basic difference over here. Here the C was on the augment part. Okay, the C was in the augment part. So determinant did not help us because the determinant did not involve the C term. The C is outside the determinant. So we had to go for rank. But if you look at this question, C is in the determinant portion, in the coefficient part, not in the augment part. So here you should get your answer from the determinant itself. You don't need to do any rank operation. Okay, because here your augment matrix would be C1, 5, 3, 3, 6. We don't need to do the rank operations because for no solution we know one of the criteria is determinant 0. There is other criteria also, but this is one of the criteria. And this should give you the answer because C is in the coefficient part. So that means this determinant must be equal to 0. So you would be having 3C minus C equals 0. So your C value would be 1. So C value 1. So we did not require the row operation here because C is right there in the coefficient portion. Okay. Let's take a look at another question. Okay, so this is EC 2022. Consider a system of linear equations. The matrices and the augment parts are given. Again, which is true, you need to find the nature of the system of equation. So the first thing you should be doing is write this in the augmented form. 1 minus root 2, 3 minus 1 root 2 minus 3 augment 1, 3. Do some row operations. Obviously here your determinant concept will not work because this is not a square matrix. So the only way to do it is rank. So rank operation should be easy. If you just add up the two rows, one of the rows is becoming 0 and something is going to remain over there. So just make your conclusion from here quickly. Tell me what should be the conclusion. Option C correct. No solution, option C, because if you add up the rows, this row, this addition, all these positions are becoming 0, 0, 0. If you add this 2, this is becoming 4. So rank of A part is 1, rank of the argument still remains 2 because this position is not becoming 0. So that means no solution. Okay, simply it comes from observation, no need to do any calculation. Okay, another question. 2023. All right, so this is the question. This is now not asking for the nature of solution, it is directly asking for the solution itself. Okay, so it is saying choose the set S, solution set S corresponding to the system of equation. So that means S represents the solution of the differential equation. Sorry, solution of the system of equation. Okay, so just try to solve the equation, that's it, nothing to be done here, just normally try to solve the equation. So here I can very easily, remove x from the equation. So x equals z. From here I can again put the x value. X is z. So that would be z minus 2y plus z equals 0. So that would be y equals z, I guess. So I'm getting y equals z, x equals z, right? My solution set should be looking like x, y, z, which is the variables present in the question. Okay, I have got x equals z, I have got y equals z, and I have not got anything related to z. So we'll be keeping z as z itself. So if I take z common, it's 1, 1, 1, and I can see this looks like option A, right? Parameter common 1, 1, 1. Parameter belongs to real number. So obviously here z belongs to real number. If you put any real number, this looks like that solution. It's simply solving a system of equation. There is no concept involved. Okay, so moving on. Mechanical 2022 system of equation. Now this system of equation is represented in a little bit different way. Generally we write a x equals b, but this is written in a little bit different way. Okay, now first I want this to be written in a conventional manner, then it's easy to think. I don't want to complicate anything. Okay, so the very first thing that I'll do is I'll take a transpose on both sides. Okay, I'll take a transpose on both sides. Now if you remember property of transpose, AB transpose would be B transpose A transpose, right? So if I consider this as my A matrix and this as my B matrix, so AB whole transpose will become B transpose A transpose, right? So first of all, B transpose, that means transpose of this 2 cross 2 matrix will be 2, 5 minus 2 alpha, alpha 1. Okay, this is a row matrix. This is a row matrix xy. If I take the transpose, it becomes a column matrix. So xy. Right side, if I take the transpose, it becomes a column matrix 0, 0. So now this has come into our conventional format. So it's easy to think. Okay. Okay. Now it's asking that the parameter alpha involves a real parameter alpha and has infinitely many non-trivial solutions. Now I told you before, non-trivial means the ones which are non-zero. Okay, so forget about non-trivial. It's saying it has infinite solution. So let's directly go into the criteria for infinite solution. Achha, one more thing, you can see this is not a non-homogeneous system of equation. This is a homogeneous system of equation, right? This is a homogeneous system of equation because you have the constants as 0. So this is the easier case, not the difficult one. The homogeneous case. Now remember, your homogeneous system of equation would have a unique solution or no solution. Sorry, unique solution or infinite solution. The no solution case is not present over there. So if the determinant is non-zero, no unique solution. If the determinant is 0, then infinite solution. So the basic idea here is determinant equal to 0. That directly corresponds to infinite solution because we are dealing with a homogeneous system of equation. So determinant 0 would be 2 minus 5 alpha plus 2 alpha square equals 0. So 2 alpha square minus 5 alpha plus 2 equals 0. So we can get this factorized. So 2 alpha square minus 4 alpha minus alpha plus 2 equals 0. So that would be 2 alpha common, alpha minus 2 equals 0. So alpha value would be 2.5. Okay, alpha value would be 2.5. But the objective is not to find the alpha value here. The objective is, this is the special value of alpha they are talking about. They are saying that it involves special values of alpha. So this is that special value of alpha for which the infinite solution case is happening. Now it is asking for this value of alpha, what are the possible cases of x and y? Okay. Now again, you can see there is special values of alpha, what is or are. Okay, so this is again important, is or are, so that means there can be more than one correct answer. Okay, it is asking for is or are, multiple correct answer question. All right, so let's place x alpha values one by one. All right, so this is our system of equation. I'm getting this off the board. Okay, so if alpha value is 2, let's write the equations, or let's just place the alpha value 2. If I place the alpha value 2, then this matrix becomes 2 2 and 1 1 xy equals 0 0. So if you multiply this, you can see you're getting the same equation, repeated same equation. The first is 2x 2y equals 0, next is x plus y equal to 0. So same equation. So we are getting just one equation, which is x plus y equals 0, right? So x plus y equals 0. Now, which of these satisfy the equation x plus y equal to 0? I can see option A satisfies x plus y equal to 0. B doesn't satisfy, C doesn't satisfy, D doesn't satisfy. So for alpha equals to x equals to y equals minus 2, that's one solution. Let's now check for alpha equals half. Okay. So if alpha value is half, again this would be 2 half, and if alpha is half, so that would be 4 1 xy equals 0 0, right? So again the same thing, we are getting the same equation, repeated same equation twice. 2x plus half y equals 0 and 4x plus y equal to 0, they are the same thing. So I'll just take one of the equations, which is 4x plus y equals 0, and again check which solution satisfy this equation. If x is minus 1 and y is 4, so I can see option B is satisfied, option C is not satisfied, option D is not satisfied. So that means A and B are the correct answers. Okay, one for alpha equals 2 and one for alpha equals half. Okay. All right, so again moving on from here. So this question is asking the value of x3 rounded up to the nearest integer. So we have a system of equation. We need the value of x3. Okay. So obviously we don't want to solve the 4 equations that we get. Right? If I multiply this, I will be creating 4 equations with 3 variables. So obviously I don't want to solve 4 equations and get one answer. There has to be some faster way. Okay. So first of all, let's take the matrix that we have, which is 1 3 2 2 2 minus 3 4 4 minus 6 2 5 2. Augment it and let's get the constants 1 1 2 1. Okay. Now we need the value of x3, only x3. So obviously I don't want to solve the system of equation. So let's try to reduce this matrix as much as possible. The very first thing that we can see, with the help of this row, we can make this row completely 0. It's just a multiplication of 2. So if I do the operation r3 dash equals r3 minus 2 times r2, that would make it 1 3 2 augment with 1 2 2 minus 3 1 0 0 0. The row which is becoming completely 0, I want to place it right at the end. So I'm writing it at the end 0 0 0 0. Okay, so the third row I've written at the 4th position, and the 4th row I'm writing in the 3rd position, which is 2 5 2 1. Okay, now let's do some more operations. With the help of this one, let's make this position and this position 0. So that would involve r2 dash equals r2 minus 2 times r1, and r3 dash equals r3 minus 2 times r1. Okay, so if I do this, I'll be having 1 3 2 augment with 1, and if I do a subtraction, that's 0. 2 minus of 6, that's minus 4, minus 3 minus 4, minus 7, 2 1 minus 2 minus 1. Then again the same thing, 0, minus 1, minus 2, and minus 1 0 0 0 0. Okay, so we have got something like this. We want to simplify this as much as possible. Okay, let's move out all the minus that we can see, and let's interchange this two row because I want this one in the upper position. Okay, that will help me for the next computation. I want the one in the upper position, so I'll interchange the rows and multiply two minus signs with row 2 and row 3. So I'm not just writing the operations, I'm directly writing the matrix that I will get. So 1 3 2 argument 1. I'm interchanging the rows, multiplying with the minus sign. So 0 1 2 1 0 4 7 1 0 0 0 0. Okay, now I've got a 1 here. This 1 is helpful for me. With this 1 I can make this position 0, right? So again, one more operation I'll be doing. So r3 dash equals r3 minus 4 times r2, and that will give me 1 3 2 augment 1 and 0 1 2 1. If I do a subtraction, so that's 0 0 minus 1 minus 3 0 0 0 0. Okay, I have reached a very good place. Now if I convert this back to the system of equation, then if I want to write the system of equation corresponding to this row, that would mean 0 times x1 plus 0 times x2 minus 1 times x3 is equals minus 3. So I have converted this row again back in the equation format. So that means x3 equals 3, and we have got our direct answer. Okay. So the idea was to make the matrix as much simplified as possible to reach our direct answer. Okay. So we did not solve the system of equation. We just kept on simplifying, trying to reach the rank of the matrix. From there, we got the value of x3. Okay. So I hope this is clear, this basic level of computation. No concepts involved. Moving on. So this is a question from 2019. System of n homogeneous linear equations containing n unknowns will have non-trivial solutions. Okay, so here the terminologies are important. System of n homogeneous equation. So the important thing is homogeneous, non-trivial solutions. And what should be the determinant value for the criteria? Come on, let people answer this. Come on, guys, answer this question. Very simple, straightforward concept question. Homogeneous, non-trivial. Something which I talked about right at the beginning. What is the condition for homogeneous and non-trivial? What should be the determinant value? Yes, correct. C, option C, which is value 0, correct. So non-trivial for homogeneous basically goes to the case of infinite solution, and infinite solution is basically given by determinant equal to 0. So that was the direct observation. Okay, so determinant should be 0. Great. All right. Let's take a look at this question. The set of equations are given. The question is directly asking for infinite solution. What should be the value of A? Okay. So your first work should be to write this in the augmented form. So the augmented form would be 1 1 1 augment 1 A minus A 3 5 5 minus 3 A 6. Okay, and the question is asking for infinite solution. So obviously the very first thing should be, for infinite solution your determinant will be 0. But I will always suggest you don't go for the determinant, because that will be a trap for you. Because if you do the determinant, maybe you will get two values of A, because there are lots of A's spread out in the coefficient part. So there is a high possibility that you will have a quadratic in terms of A, and quadratic will give you two values. And maybe there's a very high chance that both those values will be present in the option, and you will be confused which one is the correct answer. Because determinant 0 also corresponds to infinite solution. So one of the value corresponds to no solution, one of the value corresponds to infinite solution. you will not be able to understand which one corresponds to infinite and which one corresponds to no solution, because both the things will be present in the option. So never go for determinant, always go for the rank, because the people who are setting the gate question paper, they will not set it easy for you. They don't want you to get the answer from determinant, otherwise they will not frame the question that way. The question will be in such a way that you will get the answer only after the rank calculation. So best thing is directly go for the rank calculation, don't think about the determinant. So the very first thing we'll do with the help of this one, will make this position and this position 0, and also keep an eye for the values. At any point, if this becomes easy, we'll try to put the values from the options and see what is happening. Okay. So we want to do R2 dash equals R2 minus A times R1, and R3 dash equals R3 minus 5 times R1. Okay. So if I do these two calculations, I'll get 1, 1, 1, augment 1. So this becomes 0, and minus 2a, 3 minus a, 5 minus a. Then this line becomes 0, minus 5 minus 8, minus 5, a minus 5, and 6, 6 minus 5, that's 1. Okay. All right. Now, I think from here we should get our answer. Let's not simplify this any further, because there are lots of A roaming around. So if I try to simplify, the A things will make it complicated. Let's try to observe the options here. See, let's keep in mind, we want infinite solution. Infinite solution means one of the row will become fully 0. One of the row will become 0 means one row will be same as the other row. If one row is same as the other row, then obviously after a calculation one of the rows will become 0, and we will come to the infinite solution case. Okay, so this idea should come to your mind. So I can see these two elements are matching, no problem. I want these two elements to match as well, or let's make it more easy. I want to match these two elements also. So what value of A will make this one and this one same? Obviously you can see A4 will make this minus 8, this is also minus 8, but we should check the other options also. Okay, we shouldn't conclude from here. If I place the 4 value over here, 3 minus 4 is minus 1, 4 minus 5 minus 1, again same. If I place the value over here, 5 minus 4, 1, and over here also 1. So if I take A value 4, both the rows are becoming 0. That means after one line of calculation, one row will be completely 0. So rank of augment part and A part will become 2, and we will get infinite solution. So from here we can say the value of A is 4 without doing any further calculation. Okay. Let's do this question. Let this be the last question for today. Again, it's a is and are question, so more than one correct answer is possible. Always pay attention to is and are. More than one correct answer can happen. So I think this is a very easy question. Achha. Wait, one more thing. You will not be able to answer C and D. Okay, I just did not look at the options. You won't be able to answer C and D right now, provided if you don't know what is eigenvectors and what is positive semi-definite matrix. Okay, so positive definite matrix. So let's imagine for now that options C and D are invisible to us. Let's imagine for now, because once we have discussed that idea, we'll be able to comment on that. Right now, let's only look at option A and B. So option A is saying if this has a unique solution. Okay, so does this have a unique solution? So we need the determinant. Let's do the determinant. Determinant will be if I expand along the first row, I'll be getting 2 minus 1 plus 1 times minus 1 and 0. So that would be 1 minus 1, 0. So determinant is 0. Determinant 0 means definitely not unique solution. So this is not happening. So this definitely must be occurring. Does not have a unique solution. Right now, I am not commenting on options C and D, because to do C and D, you need to have the idea of eigenvalues, okay, and eigenvectors, which we will do in our next class. So in our next class, when we have discussed this concept, we will come back to this question again. For now, I will just tell you that C is also a correct answer here. D will not be a correct answer. D will not be a correct answer because these conclusions can be made from eigenvalues and eigenvectors. Since I have not yet taught that topic, so I'm skipping option C and D for now. Let's just do option B. But keep in mind, option C is also correct answer. We'll come back to this question again in the next class. Okay. All right. So let us conclude today's class here. We will be continuing this same linear algebra concept and moving on to eigenvalues and eigenvectors in our next class. Okay. So good night, everyone. Bye bye.